Hi everybody, I thought we could take a look at the stations, the trig word problem on scatterplot stations. Station 1. Top of the Eiffel Tower is viewed from a distance of 200 feet. The angle of elevation is 79.2 degrees. We want to know the height of the tower. Estimate to the nearest foot. So it looks like I have opposite and adjacent. Tangent 79.2 equals tower over 200. So the tower height is 200 tan 79.2. And if I pull out my calculator, 200 tan 79.2. Make sure your mode is in degrees for this problem. It's not a trig graphing problem. It does deal with degrees. We get that the tower is 1048.437 feet. They said round to the nearest foot, and so I'm going to say 1048 is the height of the balloon. That's part A. Part B, red balloon was released from the top of the tower. Ooh, a little balloon. And when it has reached 200 feet above the tower, we want to know the angle of elevation. So what's this angle of elevation? Well, I see this as a new triangle. Looking for this angle. This is still 200 feet. We found out that the height of the tower is 1048, and we're adding 200 to that. So 1248 feet here. We've got the opposite, we have the adjacent, and we're looking for theta. So in part B, let's say the tangent of theta is 1248 over 200. And if I'm solving for theta, remember, I need to do the tangent inverse of both sides. So theta equals tangent inverse 1248 over 200. Let's ask our calculator what that'll be. Tangent inverse 1248 divided by 200. And I get 80.895 degrees as our angle of elevation. Okay, flipping quite high. We have to really crane our neck up to see that. So there's problem 1. What about problem number 2? Problem number 2, the length of the longest airplane propeller was 22 feet 7.5 inches. If I make that all inches, 22 feet times 12 inches plus 7.5 inches. So I get 271.5 inches. That's the diameter. So the radius would be that number divided by 2, or 135.75 inches. Okay. Engines that turn the propellers at 545 revolutions per minute. Well, we remember that if we're dealing with angular linear velocity, our linear velocity is measured in radians. So we need to convert this by multiplying by 2 pi radians per revolution. And so 545 times 2 is 1090 pi radians per minute. And we know that the formula linking linear and angular velocity is v equals r times omega. So we can say radius of 135.75 inches times 1090 pi radians per minute. Per radian. So the radians will cancel and I'll have inches per minute. But the directions say how fast in miles per hour. Oh no! So I'm going to get this inches per minute thing, and I'm going to have to convert to miles per hour. All right, well, let's find out what 545 times 2 pi times 1355.75 is. Wow, that's a big number. That's 546,485.3.611. Those are inches per minute. And I need to convert that to miles per hour. So I know that there are 1 foot as 12 inches, and 5,280 feet is 1 mile. So I'll be able to get to miles, but I'm still in minutes. So I have to multiply by 60 minutes over an hour. Okay, so that's this big number times 60 divided by 12 and divided by 5,280. And we end up with 440.202 miles per hour. Wow, that's a fast cargo plane. Okay, so there's our angular speed of the propellers. That's part A, and here's part B. Approximately how fast did the tip of the propeller travel. Okay, that's station 1, problems 1 and 2. Station 2 says orbital fashion, the fashion industry's orbital mind control lasers passing directly overhead 70,000 feet. A minute later, the angle of compression is 42 degrees. This is U. This is 1 minute. Approximate the speed. Well, remember, speed is distance divided by time. So I've got the time. I need to find this distance. Okay, well, we know this angle. We know this side. We're looking for this side. So that's opposite and adjacent. How about tangent? 42 equals 70,000 over d. So d equals 70,000 over tan 42. Okay, that's our distance divided by time. Time is 1 minute. So this is feet per minute. Let's ask the calculator what 70,000 over tan 42 is. 70,000 divided by tan 42. I'm going to check just to make sure I'm in the right mode. Good. So I get 77742.876 feet per minute. That is a fast satellite. Okay, that's number 1. Number 2 on station 2. Ooh, this is a big problem. So we're on a splash park ride. It's got a downhill, it's got a straightaway, it's got a downhill. And we're told that this is 15 feet. We're told that this is 15 feet. We're told that this is 35 degrees, that this is 25 degrees. Now, this is part of the ride, this is part of the ride, this is part of the ride. And we know that this distance is 100 feet. Okay, so let's start by finding this piece. That's D1, and that's opposite and hypotenuse. So the sine of 25 is 15 over D1. D1 is 15 over sine 25. 15 divided by sine 25. I get D1 equals 35.493 feet. Now, what about D2? Well, I can do the same thing and say sine of 35 equals 15 over D2, where D2 equals 15 over sine 35. 15 divided by sine 35, and I get d2 is 26.152 feet. But that's not the whole ride. See, I still need to find d3. d3 is not 100. 100 is from here to here. d3 goes from here to here. See this distance here and this distance here? Well, they need to be subtracted from 100 to get d3. So I've got to find this distance, and I've got to find this distance. Let's call them d4 and d5. I know that cosine 25 is d4 over, oops, tangent 25 is d4 over 15. So 15 and 25 is d4. And over here I can say tangent 35 equals 15 over d5. 15 over d4. So I really want this to be 15 over 1025. So here d5 is 15 over 1035. So d3 is 100 minus d4 minus d5. So 100 minus 15 divided by 1025, don't forget to close that parentheses, minus 15 divided by 1035, don't forget to close that parentheses. And we get that d3 is 46.410 feet. So the total distance of the ride is d1 plus d3 plus d2, which is going to be 26.152 plus 46.410 plus 35.493, and I get a total of 108.055 feet. Woof! How long will this ride last? Well, you're expected to go 60 miles per hour. Oh no, this is in feet. I better convert it to miles. I know that in 1 mile is 5,280 feet. So if you divide this number by 5,280, you get 0.024649955 miles. And we're going 60 miles an hour. Remember that distance equals rate times time. So if we take the distance and divide by the rate, we get the time. I'm going to take this distance and divide it by the rate of 60 miles per hour, divided by 60, and I get 0.000341 hours. Well, of course, a splash park ride doesn't take a number of hours. Let's multiply that by minutes. So if we multiply that by 60 minutes in an hour, that's going to be 0.0204 minutes. Yeah, let's go for seconds. If we multiply by 60 again, we get 1.227 seconds. A very short, fast ride. Hope you enjoy it. Wow, there was a lot of parts to that problem. Number 2 on Station 2. Let's take a look at Station 3. Oh, a 5-foot-high mutant ant casts a shadow of 4 feet, after on the scale. Find the angle of elevation to the sun. So we're looking for theta. Well, tangent of theta is 5 over 4. And if I take the inverse tangent of both sides of the equation, I get that theta equals tangent inverse 5 over 4. Inverse tangent, 5 divided by 4. I get theta should be 51.340 degrees. Okay, 2. While waving goodbye to your parents who are embarking on a celebratory cruise, you notice the ramp they are walking up starts back 48 feet. There's the side of the ship. There's the ramp. Is 48 feet back from the side of the ship, and ends at a door 14 feet up the side of the ramp. What was the length of the ramp? Well, I can use Pythagorean theorem, or if I know my Pythagorean triples, I can find out that the ramp is 50 feet long. What's the angle the ramp makes with the ground? Well, tangent theta equals 14 over 48. If we do the inverse tangent at both sides, we can find theta is the inverse tangent of 7 over 24. Inverse tangent, 7 divided by 24, and we get 16.26. Theta equals 16.260 degrees. That's the angle the ramp makes with the ground, and station number 3 was pretty fast. How about station number 4? Station number 4, two friends, Ms. Stoat, Mr. Weasel, have found part of a treasure map. They know there is buried treasure on an island nearby. Reading the map one way, Mr. Weasel heads off in a boat at 1 p.m., sails north 34 west. 34 west at 1 p.m. Reading the map a different way, Ms. Stoat leaves a half hour later in the same port and sails out north 56 east. He goes much faster, and he's traveling longer, so his will be longer. And this is 56. 34 plus 56 makes a nice right angle there. How far have they traveled? Well, at 3 o'clock, she calls him, Stoat Weasel. She calls him and says, "Hey, I found a treasure, so you should come to me." And she's been traveling 1.5 hours at 18 miles per hour, and so we get 27 miles. So she traveled 27 miles. He was going at 24 miles per hour from 1 p.m. to 3 p.m., so for 2 hours. And so he traveled for 48 miles. Okay, how far apart are they at 3 p.m.? Well, I've got a right triangle. I know this is 48. I know this is 27. So I'll use my Pythagorean theorem. 27 squared plus 48 squared. Take the square root. And I get 55.073 miles apart. It's going to take him a little more than 2 hours to get to her. And if Mr. Weasel wants to sail to where Miss Stoat is, on what bearing must he sail? So I'm going to draw a compass rose up here. And I know that this is 34 degrees. So this is 34 degrees. But what I'm looking for is what bearing? Well, the bearing is made up of that 34 degrees and this angle inside the triangle called theta. So if I can find theta, I could add it to 34 to get Mr. Weasel's bearing angle. Okay, so inside the triangle. Well, this triangle with 48 and 27. Oh, well, that's tangent. Tangent theta is 27 over 48. Theta equals tangent inverse 27 over 48. Tangent inverse 27 divided by 48. I get theta is 29.358 degrees. Remember, that's not the bearing angle. We still have to add 34 degrees to that. And so we get Mr. Weasel should go south 63.358 degrees east. Weasel wants to go south 63.358 degrees east to get to Miss Stoat. Okay, that's station 4. How about station 5? Ooh, Tarzan is swinging back and forth. At time equal to 2, Tarzan is at the end of one swing to negative 23. and at time equal to 5, he reaches the other end of the swing at 17. Okay, so it looks like I have a low point at 2, -23, and a high point at 5, 17. So I think this is a negative cosine graph. This is part A, sketch a sinusoid. Part B, write an expression for Tarzan's distance. These are the distances as a function of time. So we need a d value, 17 plus -23 divided by 2, -6 divided by 2, -3. A is 17 minus a minus 3, or 20. B. Well, B is 2 pi over the period, but I only have half a period. 5 minus 2 equals 3 is half a period, so 6 would be 1 period. 2 pi over 6, 4 pi over 3 is our B value, and our C is our starting X, so C equals 2. So my equation here would be y equals -20 cosine pi over 3 x minus 2, close 2 parentheses, minus 3. Ooh, as a function of time. So put a t there. So that's part B. C, predict y when t equals 2.8, 6.3, and 15. Well, these are all things that are easiest to do on the table feature of my calculator. So let's type the function in, -20 cosine pi divided by 3, x minus 2, close 2 parentheses, minus 3. And we'll go over to, I'm actually going to turn my old stop pad off. We're going to go over to our table, and we're going to type in 2.8, and we're going to type in 6.3, and we're going to type in 15. Okay, and so we get -22.99, so at 2.8 seconds, we get -22.99 feet. Huh, that's very near the end of our swing. Am I in the right mode? This is a trig graph. Oh, look at that. Let's try that again. There we go. So 2.8 seconds on -16.38. And because we need that third decimal place accuracy, 383 feet. At 6.3 seconds, so we'll go over here and type in 6.3, we get positive 1.1582 feet, and at 15 seconds, we get exactly -13 feet. Okay, that's part C. Part D, where was Tarzan when Jane started the stopwatch? Well, that's time equal to 0, because at 2 he was at -3, so that's equal to 0 at 7. So at D, y of 0 equals 7. And part E, find the least positive value for which Tarzan is directly over the riverbank, i.e. y equals 0. So if I look at a graph of this, and I do need to change the viewing window, 0 to 10, steps of 1, and the y minimum was -22, and the y maximum was positive 17, steps of 5. So we're looking for the first time Tarzan is over the riverbank, or y equals 0, which I think is right there. So let's calculate that's 0, bring our cursor close to that point of intersection. Pass down, the planes back up. We want to be on the left side of that point of intersection. We want to be on the right side of that point of intersection. We want to guess. and I get 0.356 seconds used directly over the riverbank. Okay, that was station 5. Let's take a look at station 6. A tsunami, called the tidal wave because its effect is like a rapid change in tide. Fast-moving ocean wave caused by an underground earthquake. Water first goes down from its normal level, then rises an equal distance above, and comes back down to its normal level. So that looks like a negative sine graph that we're going to be doing here. Period is 15 minutes. So we know the b value is 2 pi over 15. Tsunami with an amplitude of 10, and the depth of water is 9. Assuming the depth of water varies sinusoidally, predict the depth of water at these various times. Okay, well, let's build that model. We've got y equals negative 10 sine 2 pi over 15, x minus 18 minus 0 plus 9. So I'm going to type this into my calculator. Negative 10 sine 2 pi divided by 15, x minus 0 plus 9. And I want to know at 2 minutes, at 4 minutes, and at 12 minutes. So time, depth, 2, 4, 12. 1.569, and these are in feet, meters. At 4 minutes, we have negative 0.9452 meters. That means all the water is gone. Here's water level 0. And we've sucked water out from underground. 12 minutes. 12 was 18.511 meters. That's a very tall wave. You don't want to be there when that crashes. Okay, so there's part A. Part B. According to your model, the minimum depth of water. Well, we know that the d value is 9, but the amplitude is 10. And so this minimum depth is going to be negative 1. And then it says, how would you interpret this answer in terms of what will happen in the real world? Well, I just mentioned that. Since we're going to a depth of negative 1, that means the water gets sucked out from under the ground. All the water goes away. We get down to 0 water, and then the water is sucked out of the bottom of the sea to a depth of 1 meter below the surface of the water. All that water is sucked out. So negative 1 meter is my answer to part B. Between what 2 times is there no water here, from here to here? And that's easiest if I go to my graph. Do I want to change the viewing window? Yes, I want to change the viewing window. Well, I can actually catch it here. So I can calculate 0. Zero, positive, negative 1, C. I got 2.673, and we want to find that other 0 going over here. Enter. On the right side of that, enter, enter. And 4.827. So between these 2 times, or at these 2 times, between which 2 times is there no water? So I think between these 2 times there's no water. The wavelength is the distance between the crest the wave travels in one period. It's also equal to the distance between two adjacent crests. Tsunami travels 1,200 kilometers per hour. Well, this is 15 minutes for one period. So we know that rate divided by distance equals rate times time. So if I take my rate of 1,200 kilometers per hour and I multiply by my time, 15 minutes or a quarter of an hour, I get 300 kilometers between waves. So the first wave comes in, and then 300 kilometers away is the next wave starting to build. Alright, there's station 6. Let's take a look at station 7. Adrian is hungry for donuts, so he runs at a speed of 40 miles per hour in the direction of north 63 west. North 63 west. From his home, there's his home, there's the donut. After 1 hour, and he's running at 40 kilometers an hour, so this is 40 kilometers, he gets a text from his grandparents and they need his help. He changes direction north 27 east. North 27 east. And he runs for 1.5 hours. So that's going to be longer than this. This has to be 27. So this is 63. This is 27. So there's a right angle. And I think this is our triangle. But I'm not sure. Maybe our triangle comes past perpendicular and actually wants to run this way. We'll know soon enough. Okay. When he's done helping his grandparents, on what bearing must he run to get home? And how far is he from his home in South Bay? Well, he ran for 1.5 hours at 40 kilometers an hour. So that's going to be 60 kilometers. So we've got this right triangle with 40, 60, and we want to find his distance home. So we use the Pythagorean theorem, and we end up with 60 or 40 squared plus 60 squared, and then we take the square root. Oops. We take the square root. Square root of 5,200, and we get the distance home is 72.111 kilometers. I hope you enjoyed this donut. Now, what about the bearing he needs to take? So if I draw a compass rose up here, it looks like this is the bearing. So, what do we know? Well, I know that, what do I know? I know that this 27 is the same as this 27 here. And I can find this angle, theta, inside this triangle. If I do tangent theta equals 40 over 60, so theta equals tangent inverse 40 over 60, I'll get theta. And then if I subtract 27, I'll get d. Now, if d turns out to be negative, I've drawn the picture wrong, and it's really this other picture that we need to do. I'll take it up front. Okay, let's see what happens. We get inverse tangent, 40 divided by 60. Hey, what's my mode? Gotta be degrees. Don't forget to change that. So, 33.69 degrees is theta. We want to take 27 degrees away from that. And so we get a bearing of 6.69. So he wants to head south 6.69 degrees east. Okay, there's station 7. Station 8. Once upon a time, there was a bat named Rudolph. Rudolph had a hankering for saguaro fruit. He knew right where to find them. Eager to have them right away, he flew at a speed of 360 miles per hour from his cave at a direction of north 47 west for 30 minutes. So half an hour at 360 miles per hour means he travels 180 miles. Okay, so that's where he gets his fruit, and that's his home. And then what? He eats the fruit, then he realizes he wants some more. He flies in the direction of south 40 feet west, south 40 feet west, 47, there's our right angle, and he flies for 45 minutes, so even longer. So that's 3/4 of an hour times 360 miles per hour, and we end up with 270 miles. 270 miles this time. Okay, find the distance from the second cactus back to his house. Okay, so that distance is something I can find with Pythagorean theorem using these sides. 270 squared plus 180 squared, square root of that answer. And I get that that distance is 324.4996. So that's pretty much 324.5 miles. Okay, and then on what bearing must Rudolph travel? So compass rose. Rudolph wants to head north this many degrees east. Well, because this is 43, this is 43, but that's not our whole bearing angle. Our whole bearing angle includes this theta, theta plus 43. Conveniently, theta is this angle inside this triangle. So if we do tangent of 27, right, tangent of theta equals 180 over 270, and then we do the inverse tangent of both sides, we should find that theta, inverse tangent, 18 divided by 27, I'm in degrees, that's good. So we know this is 33.69 degrees. We want to add our 43 degrees to that. And so we should fly north, and then 76.690 degrees east. There's his bearing, and there's his distance to get back home. Let's take a look at station number 9. Station number 9. Oh. But I have to give Ms. Keene something, so hold on a second. Ms. Keene, here's some handouts for you. Okay, station 9. 007's latest spy car allows him to fly. He's in hot pursuit of evil corporate tax dodgers who fled their secret Volcano Island base for their even more secret high-altitude balloon base, altitude 60,000 feet. If he takes off at an angle of 10 degrees and traveling at a speed, right, he's traveling on this distance, his speed is 250 feet per second. It sounds pretty fast. How far does he need to travel in order to reach the height of the balloon? So we want to find that distance. That's opposite over hypotenuse. So the sine of 10 degrees equals 60,000 over d. So d will equal 60,000 over sine 10. So remember, we want to be in degrees for this. Then we do 60,000 divided by sine of 10. Wow, he's got a long way to travel. 3, 4, 5, 5, 2, 6.229 feet. Well, it seemed like he was going really fast, but he's got a lot of feet to travel. Remember, distance divided by speed will give us time. If we take that number and divide it by his 250 feet per second, it's going to take him 1382.105 seconds. If we divide that by 60, it's going to take him 23 minutes to get there. Okay, how far does he have to travel in order to reach the balloon? There's part A. Part B, if it takes him more than 5 minutes to, well, it did take him more than 5 minutes to reach the balloon. It took him 23 minutes. The evil tax accountants will be able to successfully flee from justice. Sorry, 007, you weren't fast enough this time. There's station number 9. Station 10, linear and angular velocity. Let's see what we can do with station 10. Well, with these, we're given 33 revolutions per minute, and we want an angular velocity, omega. Remember, we do that by multiplying by 2 pi radians per revolution. So I get 66 pi for the vinyl LP. The smaller 45 revolutions per minute, RPM, times 2 pi radians per revolution. That goes much faster, 90 pi radians per revolution. And CDs, if you remember those, 220 revolutions per minute times 2 pi, or a whopping 440 pi radians per minute. So these are the angular velocities, but we also need to provide linear velocities. Remember, linear velocity is angular velocity times radius. So I have to multiply this by the radius of the LP. The diameter of the LP was 12 inches, so the radius is 6. So I need 66 pi times 6, and I get 113.097 inches per, and these are minutes. The 45, that was smaller, that had a 7-inch diameter. So we want to multiply this number by half of 7. So 90 pi times 3.5, and we get 989.601 yikes inches per minute, much faster. And 220, so 220 has a diameter of 5.25. I want 5.25 cut in half the radius. So 440 pi times 5.25 divided by 2. And I get 3628.5395, and those are inches per minute. Wow, those CDs spin fast. Okay, station 10. We just had to multiply by 2 pi to find angular velocity, and then once we had angular velocity, we multiplied by radius to find linear velocity. Station 11. You're 10 kilometers away from the famous Light Flight Helium Balloon Animal Factory. One day you look out your window and you notice a giant balloon squid floating above the factory. There's a giant squid. First time you notice the angle of elevation is 19 degrees 20 minutes. You go off, make a peanut butter and marshmallow sandwich. A few minutes later, you come back. You look again. While munching your sandwich, you choose. You notice at the time it's higher up. And now this angle is 31 degrees, 50 minutes. Approximately how far did it rise while you're making your balloon? Okay, and we're 10 kilometers away. So again, this is one of those draw two triangle problems. The first one, the small triangle with y, 10, 19 degrees, 20 minutes. So I can use this triangle to find y. And then I have this other triangle, this bigger triangle. This is 10, 31 degrees, 50 minutes, and this is x plus y. So here we know that the tangent of 19 degrees, 20 minutes equals y over 10. So y will be 10 tan 19 degrees, 20 minutes. And over here we can say tangent 31 degrees, 50 minutes equals x plus y over 10, or 10 tan 31 degrees, 50 minutes equals x plus y. Well, we're trying to find x, so if I take this and plug it in over here, I can subtract that amount from this to get what x is equal to. So that'll be 10 tan 31 degrees, 50 minutes minus 10 tan 19 degrees, 20 minutes. So let's take out our calculator and figure out what this will be. 10 tan 31 degrees and 50 minutes minus 10 tan 19 degrees 20 minutes. And we get 2.6998 kilometers. That's what x equals. Okay. Alright, station 12. Another cell phone satellite is being sent into space. The rocket fired at sea level climbs at an angle of 75 degrees. So this is 75 degrees. Climbs after the rocket has traveled 10,000 feet. What's its altitude? So we want to know how high is the rocket. So opposite and hypotenuse, that's going to be sine of 75 equals h over 10,000. So h equals 10,000 sine 75. 10,000 sine 75 is 9659.258 feet high. Okay, part B, satellite needs to be at an altitude of 50 miles before it releases its cell phone evil. How far will it have traveled by the time it reaches that altitude? So now we're thinking about this other triangle, still 75 degrees, but this time we need 50 miles. And we're looking for how far it will have traveled. So again, it's opposite and hypotenuse. Again, it's sine of 75, but this time it's 50 over d. So d will equal 50 over sine 75. 50 divided by sine of 75 gives me 51.764 miles is how far the rocket will have traveled. Okay. Excellent. Let's see what station... Oh, there's a part 2, a problem 2 here on station 12. Climbing the corporate ladder was never this fun. You put your 12-foot ladder up against the side of a large corporation. You notice, being a great trig student, that the ladder makes a 22-degree angle with the building. That's 22 up there, not 22 down here. This is the angle the ladder makes with the ground. How far are you from the corporation? So this is you, and this is the distance you are from the corporation. So opposite and hypotenuse, sine of 22 equals d over 12. d equals 12 sine 22. 12 sine 22 is 4.495 feet away. Okay, if there's a corporate scandal and your ladder slides down the wall down the corporation by 4 feet, it's still a 12-foot ladder. So I guess that means we're going to be further away. That distance is going to change now. How far are you now? Okay. Well, let's see. I guess we need to find out how high up the ladder was originally. So we know this is 12 feet, we know this is 22, and we want to find corporation height. So this is adjacent over hypotenuse. Cosine 22 equals the corporation over 12. 12 cosine 22 equals the corporation. So 12 cosine 22 is 11.126 feet, but then the ladder slides 4 feet down, so minus 4, 7.126 feet. Okay, so we've got this 12-foot ladder, 7.126 feet over here, and we want to know this distance. It looks like I need to use the Pythagorean theorem. But remember, it's not this plus this. This is the hypotenuse. So hypotenuse squared minus leg squared will give me leg squared. 7.126 squared equals d squared. Well, let's see what we get when we do that. 12 squared minus 7.26 squared, take the square root, and we get 9.655 is d. Okay, the ladder definitely moved further away from the corporation as it slid down the corporation. Let's take a look at problem number 13. Small furry blue people who lived in town A are going to visit their friends, pointy orange people in town B. Unfortunately, there's a mountain between the two towns. After months of discussion, they decide to build a tunnel. In order to purchase enough material to build the tunnel, they need to know how long it should be. Determine the length of the tunnel. Okay. We know that the mountain is 260 feet high. We know that part of the tunnel will go here. This is 200 feet. And mountain, part of the tunnel goes through here. And this is 150 feet. This is 47 degrees. Is our angle of elevation to the top of this, and this angle is 36 degrees. And it too is an angle of elevation. This is a right angle. Okay, I'm going to call this x, I'm going to call this y, and I don't know how long these are. I can say that there's this right triangle with 260, 41, and y plus 150. So if I do a tangent equation here, tangent of 41 equals 260 over y plus 150, I can say that y plus 150 equals 260 over tan 41. So 260 divided by tan 41 minus 150 tells me that y is 149.096 feet. That's this part. And I can repeat the process over here. I can say, okay, 260, 36 degrees, and x plus 200. And this is tangent. Tangent 36 is 200 over x plus 200. X plus 200 is 260 over tan 36. So we're going to find 260 divided by tan 36, subtract 200 to find x. 260 divided by tan 36 minus 200, and we get x equals 157.859 feet. So this part, 157.859 feet, this part 149, let's add them together, 149.096 feet, and we get a total of 306.955 feet. That's station 13. Station 14. Station 14 out of 15. You've decided to devote your life to crime fighting. You stand in the shadow of the building you need to climb in order to thwart the wicked pickle puss. Standing on top of a building with a bag of stolen Fabergé eggs taunting you. You are across the street. Standing on top of this building, you look up at 62 degrees from the ground. So this is 62 degrees. And this is 59 degrees. 50-foot building. So this is 50. We don't know what that is. We're looking for the height of the building. We know that the street is... We don't know how wide the street is. I guess that's x. Okay, so can I see some triangles here? Well, I see this little triangle. Tangent 59 equals y over x. So x tan 59 equals y. And then this big triangle, tan 62 equals y plus 50 over x. So x tan 62 equals y plus 50. Or x tan 62 minus 50 equals y. Now both of these are equal to y, so I can set them equal to each other. X tan 59. Well, the first thing I want to do is move this x stuff all to one side. So x tan 59 minus x tan 62 equals negative 50. If I factor an x out, tan 59 minus tan 62 is negative 50, and divide both sides by all that stuff. So negative 50 divided by parentheses, tan 59, close that parentheses, minus tan 62, close two parentheses, and we get x equals 231.003 feet. Okay, that's great, but we're not looking for x, we're looking for the height of the building, which is y plus 50. Well, I can find y plus 50 by doing x tan 59 and then adding 50 to it. So there's my x value times tan 59. So y equals 384.454 feet. But that's y. We want to add that 50 feet to it. Plus 50 gives me height of the building, 434.454 feet. Okay. Oh, I love station 15. So, the area of a regular octagon with side length of 10. So remember, we need area equals 1/2 perimeter times apothem here. And side length is 10, which means this is 5 and this is 5. Here's our apothem. Don't forget we need to find theta in order to find that apothem. We had a formula for that. Theta was n minus 2 times 180 over 2n, where n is the number of sides. And since we're talking about an octagon, n equals 8. So when I finish using this formula, 8 minus 2 times 180 over 2 times 8, I end up with theta equals 67.5 degrees. So now I've got this triangle, 67.5 degrees, apothem 5. I can write a tangent equation. Tangent 67.5 equals apothem over 5. And so apothem is 5 tan 67.5. Remember, we also need the perimeter. If each side is 10, and this is an octagon, the perimeter is 10 times 8, or 80. So we want 1/2 80, 5 tan 67.5. So 0.5 times 80 times 5 tan 67.5, and I get 482.843 square centimeters. That's part 1 of Station 15, and the very last problem is the area of a regular decagon has been inscribed in a circle. And so now this radius is 20. Here's my apothem, here's my x, here's my theta, here's my x. The side length is made up of 2 of these x's. I have a decagon, that's going to be perimeter 10 times the side length, or 10 times 2x, or 20x for the perimeter. So I need to find x, I need to find apothem, I need to find theta. Luckily I have a formula for theta, n minus 2 times 180 over 2n, where our n value for a decagon is 10. So we get 8 times 180 over 20, or 72 degrees. So we know that this angle is 72 degrees. There's the apothem, here's 20, and here's x. Using sine of 72, I get apothem over 20, or 20 sine 72 equals apothem. If I want to use cosine, I can find x. Cosine 72 equals x over 20. 20 cosine 72 equals x. Remember, our perimeter is 20x. So 1/2 perimeter, 20 times x, times our apothem. And so I get 0.5 times 20 times 20 cosine 72, close that parentheses, times 20 sine 72. 1175.571 centimeters squared. Okay, I hope that the quest goes well for you. Please let me know if you have any questions on these problems.